Hello, and welcome to the ninth lecture of Advanced Information Retrieval about domain-specific applications. Maybe you're wondering why you're hearing a different voice. My name is Sophia Altamer, and I'm a PhD colleague of Sebastian Hochstetter, who normally does the lecture. And my research focuses on information retrieval in domain-specific applications. This is why I'm really happy to introduce you to this topic and tell you more about the applications. And if you have any questions, you can reach out to me via email or via my Twitter account, and I'm happy to answer all the questions you have. Lecture about domain-specific applications. First, I will introduce you to what is a specific domain and which tasks do we have in those specific domains and how we characterize them. And then we will go into two domains where we recently have some research in neural information retrieval. So first one is the medical domain. Here we will discuss the task of systematic reviews or clinical decision support for patients. We will also introduce some evaluation campaigns like TREC COVID, TREC Biomedical TREC, or CLAY eHealth, where it is the main goal to get valuable data sets for the specific domains and the specific domain tasks. Furthermore, we will then discuss the applications in the legal domain. Here are the tasks of prior case retrieval or eDiscovery, very important. And then we will also introduce evaluation campaigns like COLI or the FIRE ISLA evaluation campaign. So first of all, we ask ourselves, what is domain-specific information retrieval? And so far in this lecture, there was mainly web search and extractive question answering discussed. So like as Google, which is a normal web search application. But there's not only Google out there, there are lots of other domains where there are needs for search engines and information retrieval methods. One example you can see here on the right-hand side, which is a screenshot of the TU Vienna library in search interface where you can look for the books which are stored in the library or which you can borrow from the library. So this is an example for academic search because there you have the books or papers from the academic domain, and you also have search queries coming from academic contexts with the users also being from with an academic background. So this is an example for an application of information retrieval in the academic domain, but there are lots of other domains too. So for example, the medical, the legal, or the patent domain. And here in this lecture, we will discuss two of them, the medical and the legal domain. So how is then domain-specific information retrieval characterized? And one characteristic is that the search is in databases of specific domains. So we look now at the medical domain, the legal domain, and the scientific domain as examples. And first of all, there we have a specific database containing documents coming from this domain. So for let's say, for example, in the medical domain, you would have a database of clinical trials. In the legal domain, you would have a database of prior cases or legal regulatories. Or in the scientific domain, you have a database containing all the papers published in certain area. So that's one key characteristic. Another characteristic of domain-specific applications are then the users, and the users in the domains are users with specific backgrounds, with specific knowledge. For example, in the medical domain, you could have doctors or medical researchers as users of those search interfaces. In the legal domain, you could have legals or paralegals who are looking for regulatories or prior cases. Or then in the scientific domain, the users would be academics or researchers who are trying to find prior research in their field, for example. And then additionally to the specific users, you also have specific tasks. So in web search, it is mainly ad hoc retrieval. So you have one short query and you only have, and then you go to the answer, and then most of the time you already have the answer you want to find. But in the specific domains, maybe it could be that you need to refine your queries multiple times and have a query session um, with multiple queries before you get to the first result, or before you get to have an overview of what is out there. So, for example, in the medical domain, you have the specific tasks of systematic reviews or clinical decision support. We will go more into detail in the first chapter in this. In the legal domain, you have specific tasks like prior case retrieval or eDiscovery. And then in the scientific domain, you also have specific search tasks like making a prior literature review or surveys. So in these domain-specific tasks have very different characteristics to web search, where in web search often the query is just a short text, and then you find the relevant website or document in a short amount of time. For example, in medical domain, you have long exhaustive search processes. For example, if you want to give a drug to a patient and you need to consider all the side effects of a drug. So you need to find all clinical trials which are about this drug and which use this drug. And it's very critical if you find one, if you don't find one clinical trial which is maybe relevant in this case or maybe relevant for this patient with a relevant side effect which the drug could have for using in treating the patient. So in the medical domain, therefore, it's very important to make an exhaustive search and find all the relevant clinical trials, for example. And then it's also very important that the search process itself is transparent and reliable so that you can explain how you find the documents which you found and how you decide when to stop the search process and how you decide when you found all relevant documents. It's also similar in the legal domain. Here you also have long search sessions um, which could have multiple queries. So you query not only one time, but you do multiple queries after another, which you refine, and then you hopefully find all the documents you need for example, for finding evidence for a new case, how it should be decided. And it's also similar in the scientific domain. For example, if you do a literature review, you have very long search sessions with multiple queries, which you refine, and then you find hopefully all the relevant research to this specific area. Also, what's a main characteristic here is also the specific domain language of the research area. So, and these are all characteristics which we need to address when applying neural information retrieval models to tasks in those specific domains. And those characteristics make the tasks here very different. So, and now we will go into another domain, which is the medical. Discuss the tasks which are there in medical domain. We will introduce some evaluation campaigns and also some solutions in the medical domain, how those tasks and problems are addressed. So in the medical domain, there's a lot of different textual health information. So there's, first of all, there's patient-specific information or there's knowledge-based information. And the patient-specific information is common to the health practitioners working daily with patients. So these are the health records they store about the patients. So this could be structured like lab results and vital signals, but it also could be in a narrative way, so where they document how the progress is going and how the patient is feeling every day. So this is patient-specific information, which is in the medical domain. And then there's also knowledge-based information from, let's say, research. This could be from the primary source, like original research, which is published in journals, books, or reports. Or this also could be secondary research results like summaries of research, like systematic reviews, our practice guidelines. And we will also discuss systematic reviews and the process of making a systematic review in this chapter. So because of the difference of the information sources in the medical domain, there are also different tasks. So for example, for the patient-specific information, a task for medical practitioners in their daily work could be clinical decision support, where they have the patient-specific information, but on the other side, they also need some knowledge-based information to decide what is the best treatment for every patient, where they also need to consider the current status of the patient. They need to consider all the diseases or all the characteristics of the patient, but also what the current status of the research is and what treatments are there for the disease the patient has. And another task we will discuss is the systematic reviews. They are concluding about research, about experiments, about clinical trials for certain drugs or for a given production request. And they're concluding the studies to find evidence and make a summary of the research to give some guidelines for then the practitioners which drugs to use in which cases or which side effect could occur. So doing a systematic review is one search task in the medical domain for information retrieval, and a systematic review itself is a secondary study that summarizes all the available data fitting for a pre-specified criteria to answer a specific research question. And it does this summary by using rigorous scientific methods to minimize the bias and generate solid conclusions from which the health practitioners can make decisions then for the patients. And also to verify all empirical evidence, the research in the search step must find all publications which are relevant to a research question. So therefore, it is a long and exhaustive process to do a systematic review. It's very resource and labor intensive and mostly relies on human labor. So, for example, doing a exhaustive systematic review takes like 6 months to 1 year for a whole team of professional searchers who do systematic reviews and evaluate the studies, how they contribute to the overall specific research question. And then also with the exponential growing number of publications in the medical domain, it even gets harder and more resource intensive to create those systematic reviews. And how those systematic reviews are created is followed a hierarchical approach. This is now a picture you can see from Cochrane, Austria. They made a handbook public how to do a systematic review for interventions, and made some criteria how to maintain the quality, how to maintain that all the relevant studies are in the systematic review and are found, and how to comprise the knowledge. So what they do is first that they define a search strategy and refine the research question. And then they do a first stage retrieval where most of the time they use Boolean search queries on different search interfaces, because there are a lot of online providers of different studies and not all studies are published everywhere. So what they do is that they create a Boolean query and let it run on all those different databases for clinical trials. What they also do is that they use some specific terms or categorizations like mesh terms, which they include to search for studies in this category. This is how they, in the first step, select the studies, and then in the second step, the appraisal, they first screen all the abstracts and titles of those studies and determine what's relevant there. And then afterwards, they do a more refined screening on the whole document level, where they read the whole clinical trial and find out if it's relevant to the specific research question of the systematic review. And only after those steps, there's the synthesis of the results, where they synthesize all the studies they found which are relevant to the research question and answer the research question. For example, like, an example could be the effect of the COVID-19 regulations on the psychological health of 20 to 30-year-olds. And this could be a research question. And then for this research question, they would first need to find studies, find out which of the studies they found in the first stage retrieval are relevant to the specific research question, and then synthesize and find evidence for some hypothesis. So in the systematic reviews also underlie some legal requirements for the review, and the review is required to be explainable and transparent, so that the people who do the review can explain how the results get found. It may be also, if some relevant clinical trials are missing, they can explain why they're missing. And also the search is required to be reliable and reproducible. So at a later stage, they would need to be able to reproduce which studies they found and on which basis they selected which study is included in the systematic review and which is not. And because of those requirements, so far traditional Boolean search queries and lexical matching methods are dominant in this field of IR, because with this they can easily explain, for example, why some studies didn't get found, because they only do lexical word matching, and if one word of the search query is not in the document will not get found. But this is also a huge opportunity in this field, because neural information retrieval methods can bring more contextualized knowledge and include more contextualized knowledge in the search, and can improve the search results. But at the same time, there's the requirement to make the search process explainable and reliable. And this is a very exciting opportunity in this area. Another information retrieval task in the medical domain is clinical decision support. And clinical decision support systems should provide clinicians, staff, and also patients with knowledge. And they should also consider the patient-specific information from the electronic health record of the patient, and to generate with this patient-specific information specific case advice for the treatment of one patient. And therefore, the systems should link health observations of the patient together with health knowledge. So this is also an interesting information retrieval task, where you also need to consider patient-specific information and also the current state of the research, and combine this. So now, after introducing the specific tasks which are there in the medical domain, we will go into some evaluation campaigns. So in order to advance research in those specific domains, there is data and relevance annotations needed in order to evaluate models, compare models. And therefore there are numerous evaluation campaigns which with the goal of producing research data sets. For example, there's the TREC clinical trials TREC, and here the task is to match a patient depending on the health record of the patient to clinical trials. So, and therefore you can participate in this TREC, and based on your participations, you get back some relevance annotations of the documents or of the clinical trials which your systems returns. And this is how the research is then advanced for decision support systems. Then there's also BioASQ, that is a challenge about biomedical question answering. And there's also CLAY eHealth. They have tasks about patient-centered information retrieval or consumer health search, which is also more concerning the task of clinical decision support. But they also provide tasks about technology-assisted reviews in empirical medicine. So here it is the task to do a systematic review or find clinical trials for systematic review using technology-assisted methods, like neural information retrieval methods, for example. Another very awesome evaluation campaign started last year. It's called TREC Covid, and it started because the research papers about COVID-19 were just immensely growing. Because there were a lot of publications about COVID-19. Everyone is affected by it, and a lot of clinical trials. And in order to enhance the research on IR systems to support the researchers who research COVID-19 and to support them to keep track of all the new published clinical trials, this task was created, or this challenge was created, and within this task they created a research corpus of clinical trials and studies which only relate to COVID-19, and then they also created some queries about COVID-19, like about the vaccinations, and these were the test queries for this task of retrieving evidence for COVID-19 related queries. So, and as I already mentioned, there are specific challenges in the medical domain, which are challenges also for neural information retrieval methods. For example, you have domain-specific language in the medical domain, and therefore, if you want to use neural information retrieval methods for the medical domain, it is really important that you also use domain-specific language models. So in previous lectures, there was the BERT language model introduced, and exactly the same BERT model exists, but for specific domains. So this language model BERT is then trained on either scientific domain or biomedical domain or clinical trials to represent the language of the medical or biomedical studies more precisely and more informative. So there are different models like SciBERT, which is trained on scientific abstracts of Semantic Scholar. Then there's BioBERT, trained only on biomedical study abstracts, and PubMedBERT, which is only trained on the abstracts of clinical trials. Another challenge for training neural information retrieval methods for tasks in the medical domain are the few labeled data you have in those domains. And as I already said before, there are some evaluation campaigns with the goal to create more data, to have more training data, to use neural information retrieval methods. And then, for example, you could also take relevance labels from other sources, for example, from the click logs. So if you have a search engine, you can track what the people click on, and what the people click on you can consider as relevant. And this is what, for example, was done creating the TRIPClick dataset. This is a large corpus of medical studies containing the title and the abstract of the studies and relevance annotations based on the click data of the users of the TRIPClick search database. So yeah, having few labeled data is really a challenge in the specific domains. And another one in the medical domain is the high recall setting. So it is really catastrophic if you miss a relevant document, for example, for a side effect of a drug, because it could happen that your patient has the side effect or should not get the side effect. So it is really important to find all the relevant documents or clinical trials to your given search query. So, and then the neural information retrieval approaches for tasks in those domains have a similar structure as in web search. At first, there's the first stage retrieval, which is typically nowadays done in Boolean queries, but can also be approached with dense retrieval approaches, which will be covered in the next lecture. And then in the second step, there is then neural re-ranking. And here, the domain-specific challenges need to be addressed, like the domain-specific language models or domain-specific relevance annotations or having fewer labels. And these are all challenges to consider when you create a neural information retrieval method. A lot about applications in the medical domain. I also want to introduce you to applications of information retrieval in the legal domain, and also discuss here tasks, evaluation campaigns, and solutions for tasks in the legal domain. So first of all, what you need to consider in the legal domain is that you have very different legal systems which vary a lot from nation to nation. And broad overall, you can say there are two systems. There's the statutory law system and the case law system. In the statutory law, the statutes and legal regulatories are the primary information source, and therefore it is really important if you want to solve a new legal case that you find relevant statutes and legal regulatories to this case. This system is mostly in European countries. And different to this system, there's the case law system, where precedent cases, so like prior cases which are already decided by court, are the primary source for legal evidence and not legal regulatories. So in those systems, it is really important to find all the prior cases to your case which you want to solve. And this system mainly is in the Canada, in US, or in Australia. So I wanted to focus now more on case law systems, and namely here the task of prior case retrieval in case law systems. So, and the task should lead to prior cases which should be noticed for solving a current case. So let's say a lawyer has given a current case and you want to find legal evidence for solving this case. And this is when you do a prior case search. And here, the information source is the primary literature containing the previous court decisions, how prior cases got decided. And the desired output of the search is a list of prior cases, which should be sorted by relevance or also temporal aspects. Because, like, if the decision is very old, maybe it's not relevant anymore. So the newer the decision it is, the more relevant it is. There are also some aspects which need to be considered, like hierarchical aspects, like from which court does the decision come? Like, is it from a high Supreme Court or just a local court? And some courts overrule the other one's decisions. So, and the aspects of this task are that you have a more precision-oriented task. It is not as exhaustive as, for example, systematic reviews, where it's really important to find all the relevant documents. Here, it is more important to have highly relevant cases at the top of the search. And another aspect is the domain-specific language of the court decisions, as they are written in legal narrative forms and also legally binding text. What I already said, there's the hierarchy of decisions which needs to be considered depending from which court the decision comes, and also the temporal aspects of the decisions need to be considered. As the older a decision is, maybe it's not relevant anymore to your case. Another task in the legal domain is called eDiscovery, which is short for electronic discovery. And here it is the task to discover and produce critical evidence for a case in legal litigation. And this process is subject to rules of civil procedures, and those rules are agreed upon the process. And you have a requesting party, which makes a production request for critical evidence for a legal litigation of a case. And then this process often involves review for privilege and relevance before the data is returned over to the requesting party. And in this task of eDiscovery, it is also really important to find all the critical evidence and all the critical cases to litigate a case, and therefore we also are here in the high recall setting. And similarly as in the medical domain, there are also numerous evaluation campaigns in the legal domain to enhance the research for legal information retrieval and also to create research datasets. For example, there's the TREC legal track. Here it is the task to do eDiscovery for a given production request. There's the COLI competition, which is a competition on legal information extraction and entailment for case law and statute law systems. And here they are concerned with Canadian and Japanese law systems. There's also the FIRE ILA track, which is also about precedent and statute retrieval, but here it's only concerned for Indian case law system. And then, because of the specific tasks in the legal domain, we also have specific challenges. So one challenge is the domain-specific language in legal domains, as the statutes and the cases are written in a very characteristic way and using specific terms which are specific to the legal domain. And therefore, if you want to use neural information retrieval models, there's also the need to use domain-specific language modeling. For example, there's a BERT variant called LegalBERT, which is only trained on legal documents from court listener and therefore is way better suited to embed legal domain language into a vector space. Then there's also the challenge of really long documents, which is different to web search. In web search, the queries are very short often, but then in the legal domain, if you have tasks like prior case retrieval, where your actual query, what you give to the search is the whole document or the new case, and you want to find similar prior cases to this one. So the actual query is one legal case and is very long. And you can tackle this problem of long documents if you use neural information retrieval models by breaking the documents, the queries down to a paragraph level and using methods on the paragraph level and then aggregate those to a whole document relevance. Or another approach which is used is that given a long document, you create a summary of the case or of the long document, and then you use this summary, which is shorter, as input for your neural information retrieval model. And then another challenge is that the task is more precision oriented than in systematic reviews. It's not this exhaustive, and therefore there's also the need for relevance-based re-ranking in the second stage of the retrieval. So if you want to apply neural information retrieval methods from web search to tasks in the legal domain, there's a similar setup as in web search. Again, there's the first stage retrieval, which is done with Boolean queries or dense retrieval approaches, which I discussed next lecture. And there's then the neural re-ranking stage, where you have to consider the domain-specific language of the retrieval task. You also have to consider the domain-specific relevance annotations and the challenge that you have very long queries and very long documents, and you can address this challenge by generating summaries of the cases, or you do a paragraph level approach by splitting up the case on the paragraph level. And this is also what I want to introduce you now with a method called BERT. So in BERT PLI is a neural re-ranking method for case law retrieval, and as the name already suggests, it is a BERT-based re-ranking method which re-ranks the first stage retrieved candidates for the task of prior case retrieval. And here the re-ranking is reduced to a binary classification problem. So given the query case and the candidate case, the model predicts if the two cases are relevant to each other or not. So, and what is special in this model is that it has to handle the long documents. So first the query is a long document, and also the candidate in the corpus is a long document. And it does this, or it handles this long document by splitting up the document into their paragraphs and then modeling the interaction of the candidate's paragraphs and the query's paragraph using a BERT cut approach. So it does this by splitting up the query case and the candidate case into its paragraph, and then concatenating each paragraph of the query and each candidate paragraph together, and then predicting the relevance between those paragraphs. Um, but I will also introduce it to you in the next slide. So here you can see the re-ranking approach of BERT PLI. So on the left corner down on the left lower corner, you can see the query document Q, which is split up in its paragraphs, and then it's also used to retrieve the first stage candidates, the top K candidates, and then each candidate is also split up into its paragraphs. And then for each paragraph candidate pair, all the paragraphs of the query document and all the paragraphs of the candidate document are concatenated with each other, and the relevance between the query paragraph and the candidate paragraph is predicted using a BERT model. And you need to use this splitting up because the BERT model has a limited input size of only 512 tokens. This is why you need to split up the whole document into its paragraphs and only model the relevance on the paragraph level. And then what you get by modeling the relevance on the paragraph level is an interaction matrix of all the query paragraphs with all the paragraphs of the candidate document. And this interaction matrix is then used to max pool the representations for each query paragraph. And then the document level interaction is predicted by an intentional recurrent neural network. And this then predicts if the query document is relevant to this candidate document or not. So, and by this approach of first splitting up the cases and the queries into its paragraphs, modeling the interaction on the paragraph level, and then aggregating it on the document level and predicting the relevance on the document level, this neural information retrieval method addresses the problem of long documents and also how to handle them with a BERT-based approach. So now I also want to summarize what we've seen in the lecture. So there's not only web search out there, but there's also search and information retrieval tasks in a variety of specific domains. We have targeted 2 tasks in the medical domain, the systematic reviews, which are very exhaustive and take long and a very labor-intense process, and also clinical decision support systems, which focus more on the patient-centered view. And then we've also introduced tasks in the legal domain, namely the prior case retrieval and the eDiscovery. And we've shown also a method how to address the challenges of long documents and of domain-specific language in prior case retrieval. Thank you all for your attention. I hope you enjoyed the lecture, and I hope you could learn a little bit more about applications of information retrieval methods for also domain-specific tasks. And if you have any further questions, I'm really happy to answer them in the question session. Thank you.